Now, welcome to this yet another particular lecture whereby we are going to deal with the embryology of the respiratory system. So there are six learning objectives. My name is Evans Kipkoech from Masinde Muliro University of Science and Technology, that is Kenya, East Africa. So the first objective is the introduction to derivatives of respiratory diverticulum. The second one is the separation of the laryngotracheal tube by what you call the tracheoesophageal septum. The third one is the embryology of the larynx and the congenital anomalies. Then the embryology of the trachea and its congenital anomalies. We also have the embryology of the lungs, including the 4-5 stages of lung development. And then finally, we have the clinical correlation of the lungs and the steps for production of surfactant. Now, let's start with the introduction to derivatives of the respiratory diverticulum. So, respiratory system is endodermal in origin. It's endodermal in origin. It develops from what you call the median endodermal diverticulum of the foregut. So foregut is the embryonic origin. Now, respiratory system is first seen as the midline evagination, known as the respiratory diverticulum, or what you call the laryngotracheal diverticulum. That is from the ventral wall of the pharyngeal part of the foregut. It then extends in its caudal direction and finally elongates, forming different parts of the respiratory system. Now, the next thing is what you call the tissues of origin, embryonic tissue of origin of the respiratory diverticulum. Now, respiratory system developed from 3 embryonic tissues. The first one is what you call the endoderm. The second one is the splanchnic mesoderm. The third one is what you call the neural crest cells. So the first one, the endoderm, will give rise to the glands and the lining epithelium of larynx, trachea, bronchi, and the lungs. While the cartilages, smooth musculature, and the connective tissues are derived from what you call the splanchnic mesoderm. Now, we can now move to the second objective, whereby we now deal with the separation of the laryngotracheal tube. Now, the respiratory diverticulum develops as an outgrowth of this, as an outgrowth from the ventral part of the foregut. So what have we just said? We've just said that the respiratory diverticulum developed as an outgrowth from a ventral part of the cranial part of the foregut. Now, pertaining this, we now see this how is this laryngotracheal tube formed. So this diverticulum is first seen as a midline evagination known as respiratory diverticulum, or what you call the laryngotracheal diverticulum. Now, the free caudal ends of the respiratory diverticulum grows downwards to enter the thorax, where it becomes bifid to form the right and left lung buds. Let me show you the slide pertaining that. So the distal part of this laryngotracheal diverticulum is separated from esophagus by development of what you call the tracheoesophageal septum. Now we ask ourselves, how is this tracheoesophageal septum formed? This tracheoesophageal septum is formed by growth of the laryngotracheal folds or laryngotracheal grooves from either side of the lumen and fuses in the midline, forming what you call the tracheoesophageal septum. Now, this septum will divide this tracheoesophageal tube from caudal to the cranial. So it will separate into the anterior part, which is the trachea, and the posterior part, which is the esophagus. Now, the tracheoesophageal septum is coronally oriented and extends from caudal cranially. So it extends from caudal to cranial. At the cranial part, the respiratory primordium maintains its communication with the pharynx through the laryngeal orifice, thus forming what we call the laryngeal inlet. Let me show you the slide pertaining that. So, the persistence of the communication with the pharynx forms what we call the laryngeal inlet. Now, the laryngotracheal diverticulum grows downwards to enter the thorax, where it becomes bifid to form two lung buds, or what you call the bronchial buds. Now, the next thing is the invagination of these lung buds into the pleural cavity or the pericardioperitoneal canal. Each lung bud invaginates into the pericardioperitoneal canal. The right and the left pericardioperitoneal canal forms what you call the right and left pleural cavities. That is just a brief introduction pertaining the development of respiratory system. Now let's start with the first part of the respiratory system, that is called the larynx. How is this larynx developed? So larynx developed from the cranial-most part of laryngotracheal tube. The communication between the laryngotracheal tube and the pharynx will persist, as we've just said some minutes ago, thus forming what you call the laryngeal inlet, or what you call the laryngeal orifice. The cartilages of the larynx developed from the cartilages in the fourth and the sixth pairs of the pharyngeal arches. Now, there are 6 pharyngeal arches, whereby we name them the first one, the second, the third, the fourth, the fifth, and the sixth. But after some time, the fifth one regresses or it disappears. Therefore, there are 5 pharyngeal arches: the first one, the second one, the third one, the fourth one, and the sixth one. Now, the laryngeal cartilages developed from the mesenchyme from the 4th neural crest cells. Let me show you the slide pertaining that. Now, we said that the larynx developed from the cranial-most part of the laryngotracheal diverticulum. The communication between the laryngotracheal diverticulum and the future pharynx persists, therefore forming what we call the laryngeal orifice. Now, the mesenchyme, so there is the 4th and the 6th mesenchyme will form surrounds the laryngeal orifice. These two proliferates. As a result, the slit-like laryngeal orifice becomes T-shaped. Now, let me summarize. The mesenchyme at the cranial end of the laryngotracheal tube proliferates rapidly, producing paired arytenoid swellings, What have I just said? I've said the mesenchyme at the cranial end of the laryngotracheal tube proliferates rapidly, producing the paired arytenoid swellings. These swellings will grow towards the tongue, converting the slit-like aperture into a T-shaped laryngeal inlet, and therefore reducing the developing laryngeal lumen into a narrow slit. Now, at first, the endodermal cell proliferates and completely obliterates the lumen. So the obliteration of this lumen will cause what you call the solid stage, or the occlusion of the laryngeal lumen. So what follows at the 10th week of intrauterine life, there must be a recanalization to restore the luminal structure of the larynx and the trachea. So during this recanalization at the 10th week, there is also development of what you call the laryngeal ventricles. These ventricles are bounded by folds of mucous membrane that becomes the vocal cords and the vestibular fold. Let me show you the slide pertaining that part, a bit of the larynx development. So we say during recanalization, the endodermal cells forms two pairs of folds, that is the upper pair of vestibular folds and the lower pair of the vocal folds or the vocal cords. These pairs extend anteroposteriorly in the lumen of the larynx, giving rise to what you call the folds and the true vocal cords. So the false vocal cords are the pair of the vestibular folds, while the true vocal folds are the pair of the vocal cords, or what you call the vocal folds. Now we've said also there is a pair of these recesses bound by these folds is called the laryngeal ventricle. So there is formation of laryngeal ventricles during recanalization. Now, because the laryngeal muscles develops from myoblasts in the fourth and the sixth pharyngeal arches, they are innervated by what you call the laryngeal branches of the vagus nerve or the cranial nerve 10. Now, we continue. All the cartilages of the larynx, there are some four cartilages: thyroid cartilage, cricoid, arytenoid, and what you call the cuneiform cartilages. Develops from the mesenchyme of the fourth and the sixth pharyngeal arch, except the epiglottis, which is derived from the neural crest cells. So epiglottis is derived from the neural crest cells, while all the cartilages of the larynx, that is the thyroid, cricoid, cuneiform, and the other one developed from mesenchyme of the fourth and the sixth pharyngeal arches. I told you that the fifth pharyngeal arch will regress or disappear. The muscles of the larynx develops from the mesoderm of the fourth and the sixth pharyngeal arches. Therefore, these muscles are supplied by what you call the superior laryngeal nerve and also the recurrent laryngeal nerve. So, up to date, the larynx and the trachea are innervated by what you call the recurrent laryngeal nerve. We can move to the next point. Now we move to the congenital anomalies of the larynx. So we have what you call the laryngeal atresia and stenosis. What is atresia? Atresia is the complete blockage or the obliteration of the continual lumen by several factors, while stenosis is the narrowing of the lumen, may be caused by the compression of the aortic arc or any other thing. Now, laryngeal atresia is just the complete blockage of the larynx. What causes this? This is caused by failure of recanalization of the larynx at the 10th week, therefore leading to this solid stage to remain, or the obstruction of the upper part of the respiratory tract. While stenosis may be caused by the compression of the lumen by the aortic arc. The second thing is what you call the laryngeal web. A web is just a membranous like structure in the luminous structure. So in this anomaly, the membranous web-like tissue is present in the laryngeal lumen. So what causes laryngeal web? It is caused by failure of the lumen to proliferate, therefore causing this membranous like structure to accumulate in the continuous lumen. Now let's continue. Now we flip the coin to the fourth learning objective, that is the embryology of the trachea. Embryology of the trachea is a little bit brief as compared with the embryology of the larynx, and it is direct to the point. So the trachea developed from the part of the laryngotracheal diverticulum, lying between the larynx and the point of division of the diverticulum into the bronchial buds. Now we said that the endoderm forms the lining epithelium and the glands, while the splanchnic mesoderm forms the cartilages and the smooth musculature, including the connective tissues, while the neural crest cells will give rise to the nervus, the plexus, or enteric nervus plexus, to both trachea and the esophagus. So the cartilages, muscles, and the connective tissues of the trachea developed from the surrounding splanchnopleural mesoderm, or just splanchnic mesoderm, surrounding the laryngotracheal groove. Now, up to that point, we can